This video we're going to talk about the process data table. So in the previous video we talked about the raw data table and the fact that we wanted to plot mass versus time squared. So we have the mass and we have the time. The mass has its resolution. The best we can do as an estimate of its uncertainty is the resolution, because we don't have a spread of values. We only measured it once. But for the time, we have an estimated uncertainty because it has a resolution and it has a spread calculated with half the range. So we have a time and its uncertainty. And what I want is the mass and I want the time squared. So, first step, time squared calculated from time. Easy peasy. We want the absolute uncertainty on time squared, because we want to be able to plot time squared with its error bar. Now then, if we want to calculate the percentage uncertainty on time, if we were to calculate the percentage uncertainty on time, we could work out what the percentage uncertainty on time squared would be. And if we've got the percentage uncertainty on time squared, we can work out the absolute uncertainty on time squared. And this is where we want to be. So first things first, we take our percentage uncertainty on the time. That's our estimated uncertainty divided by our average value times 100%. In this case, 14% for the second row of the data. Then we've got the percentage uncertainty on time. We're going to keep two sig figs of guard digits because this is a percentage uncertainty, as we discussed last time. Percentage uncertainty on time squared, therefore, is twice the percentage uncertainty on the time, and there's a reference for that piece of information from my A-level textbook. And once we have 14, double that. Now what I've done here is there's a rounding thing, so this is actually 13.5 when I did it in my calculator, so I doubled it and I got 27. But when I quoted this to two significant figures, I've quoted it as 14. Now, so for this example, 14%, we double it, and then we round it to two significant figures, which in this case gave us 27%, which is huge, by the way. And then we want the absolute uncertainty on time squared from the percentage uncertainty on time squared, and we just calculate that. So now we have mass and a resolution, which we can plot as mass and its error bar, time squared and its error bar. We quote absolute uncertainties to one significant figure. We're keeping two significant figures for percentage uncertainties because they're for guard digits. And when we quote a value, we've got to quote it matching the decimal places of its absolute uncertainties. So here is an example. Here I've said I can quote this time squared down to 0.001 seconds. So 3 decimal places. I then quote my number to 3 decimal places. Next we can look at the graph.